just weeks before the historic encounter of Comet C/2013 A1, Siding Spring, with Mars in October 2014, NASA's Mars Atmosphere and Volatile Evolution (MAVEN) spacecraft entered orbit around the red planet. To protect sensitive equipment aboard MAVEN from possible harm, some instruments were turned off during the flyby. The same was done for other Mars orbiters. But a few instruments, including MAVEN's magnetometer, remained on, conducting observations from a front-row seat during the comet's remarkably close flyby. The one-of-a-kind opportunity gave scientists an intimate view of the havoc that the comet's passing wreaked on the magnetic environment, or magnetosphere, around Mars. The effect was temporary but profound. Comet Siding Spring plunged the magnetic field around Mars into chaos, said Jard Espley, a MAVEN science team member at NASA's Goddard Space Flight Center in Greenbelt, Maryland. We think the encounter blew away part of Mars' upper atmosphere, much like a strong solar storm would. Unlike Earth, Mars isn't shielded by a strong magnetosphere generated within the planet. The atmosphere of Mars offers some protection, however, by redirecting the solar wind around the planet, like a rock diverting the flow of water in a creek. This happens because at very high altitudes Mars' atmosphere is made up of plasma, a layer of electrically charged particles and gas molecules. Charged particles in the solar wind interact with this plasma, and the mingling and moving around of all these charges produces currents. Just like currents in simple electrical circuits, these moving charges induce a magnetic field, which, in Mars' case, is quite weak. Comet Siding Spring is also surrounded by a magnetic field. This results from the solar wind interacting with the plasma generated in the coma, the envelope of gas flowing from a comet's nucleus as it is heated by the Sun. Comet Siding Spring's nucleus, a nugget of ice and rock measuring no more than half a kilometer, about 1/3 mile, is small, but the coma is expansive, stretching out 1,000,000 kilometers, more than 600,000 miles, in every direction. The densest part of the coma, the inner region near the nucleus, is the part of a comet that's visible to telescopes and cameras as a big fuzzy ball.